Hello everyone, welcome to the first part of a 2-episode series on gallium. In this episode I will show off the reaction between gallium and aluminium metal. Before I begin, I would like to tell you a bit more about this series I will be recording. In the first part I will show off the main reaction between gallium and aluminium, which should create an alloy called AlGa. Now, before I begin with the actual experiment, I would like to tell you some more about gallium, its history, and its properties. Gallium was first discovered in 1875 by a Frenchman called François Lecoq de Bosbandon. I'm pretty sure I butchered that pronunciation. He also discovered two other lanthanide elements, which nobody really cares about because they don't really have many uses except for academic studies. Now, gallium is probably one of my favorite elements because it has very unique properties. And you can actually see a bottle I have, which contains about 10 grams of gallium. You might be able to see it a bit in the bottle. Interestingly enough, it is a solid at room temperature, but it has a very low melting point of around 30 degrees centigrade. It can actually be molten by just holding it in your hand because of your body temperature, but I'm not gonna do that because, well, that would take too long. When molten, gallium is very similar to mercury, however, it is non-toxic. Another unique property which I'll be showing off in this video is that it reacts very destructively with aluminium zinc alloys and steel. Now, what happens in this reaction is basically the gallium metal infiltrates the structural lattice of aluminium and it causes it to become very brittle. The reaction is, or the effect is called liquid metal embrittlement. Now, what this should do is hopefully form an alloy called AlGa, which I will use in the second part of the video. I believe we can start off with the experiment. Okay, first of all, gallium is in a solid state of matter, and we have to melt it, which is why I have prepared a bottle, or a glass, sorry, and some hot water, which I will pour into this glass in order to hopefully melt the gallium. Warm. Okay, so that should hopefully melt in a bit. And in the meantime, I'm going to be preparing the aluminum plate. So, first of all, I'm going to mark down 2 spots on this plate in which I will drill a hole, 2 holes, hopefully halfway through the plate, and then I will pour gallium into it and scratch it with a sharp object in order to remove the oxide layer which is created by aluminium. Okay, well, that took way longer than I expected it to. Well, the drilling took probably around like 10 or even 20 minutes at this point, and I actually cut myself while doing it. So yeah, don't play around with tools. Okay, so in this part I'm going to pour out this gallium, which should hopefully be molten at this point, if I learn how to unlock this bottle. Oh, there we go. I'm going to pour this so you can see. Oh wow, that's cool. That's way less than I thought it would, but I guess that's 10 grams of gallium for you. Now, I'm going to, I hope you can see that well. It looks very similar to mercury, like I said. Fun. Okay, so now I'm going to scoop it up with this syringe, and hopefully that should work. I'm going to pour it into the hole. Okay, that's the first one. Okay, now that's the second one. I'm gonna try and save as much material as I can because I don't want to waste this. It was surprisingly expensive. Okay, so now the last part of this experiment. I'm going to use a knife to scratch at the oxide layer of aluminium. Now, if you don't know, aluminium reacts very easily with oxygen in the air to form a protective oxide layer. You might actually see that if I scratch this, it removes like this thin piece of oxide, and like just scratches it off basically. And I'm going to do this for both of these holes, because the oxide prevents the gallium from interacting with the raw aluminium metal. Okay, so yeah, that should do it for this part of the video. I will come back in a couple of days or so with the plate, and hopefully it should mostly turn into AlGa alloy. So yeah, see you in a bit. Okay everyone, it has been about a week since the cut of the video, and as you can see in this plate, it has slightly reacted. Now you may notice that I have also spread out the gallium on the surface of the plate because I thought it was reacting too slowly, as after 2 days it hadn't really done much except created these markings, which you can, like, I hope you can see them, it's spread out as if it were some sort of disease. Now I'm going to hopefully extract the gallium from this container, or from this plate, sorry, back into this bottle, so that when I hit it with a hammer it doesn't spill all over the place, because that would not be fun to clean up. I'm also going to try and scrape off as much of this oxide that I can into the holes to make it easier for myself to work. And hopefully we can at least try to break the plate. I suspect it might unfortunately be too thick to break, or that I haven't used enough gallium. I'm not sure exactly why it hasn't reacted as much as in some other videos I saw of this, but I guess we can try. Hopefully the reaction with its reaction with hydrogen will work better. Gallium that I can from this. I think I should probably just remove this oxide and put it to the side. Oh, that's not good. Can you hear that? I think something is reacting in this. I'm not sure why that is. I hope it's not hydrogen. Now, the reason why I was worried about the sound of gas bubbling is because when the AlGa alloy comes into contact with water, it releases hydrogen gas. At the time, I didn't realize how that might have ever happened. However, after finishing the recording, I realized that before the experiment I had washed the syringe with water, which is probably the reason for the reaction. Luckily, this wasn't really that dangerous, as the amount of possible hydrogen released had to have been extremely small. No, I don't think it's doing some damage, but I don't think it's doing as much as I had hoped. Maybe I just have to hit it stronger. Oh, there you go. Oh, some gallium spilled everywhere. Oh, So, at this point I was beginning to realize that the plate wasn't gonna budge. This is probably because the AlGa alloy was formed on a surface level and it wasn't able to react very deeply with the gallium. I suspect this was an error on my part, as the plate seems to have been too thick for the gallium to react with it well. But hey, at least I got to hit a metal plate with a hammer. In hindsight, it probably would have been better to use a slimmer plate of aluminium, but oh well, reaction is done. I hope that you found out something from this. and I hope the second part will be more exciting, because, well, I was kind of hoping that this would break in half, but I guess I just have to put in more work into this, but I don't really want to spill gallium all over my house, so I'll just do that when I'm doing the chemistry bit, because that will be done in a lab. Okay, well, thanks for watching. Be sure to check out the poll that I left in the ending of the video, or sorry, in the description of the video. I will also leave some sources for people who are curious about about this whole what was happening in this video. And well, in the second part I will be trying to react the AlGa metal, or the AlGa alloy, which you can probably see, with water, which should release hydrogen. That's why I was worried about it's like bubbling in this, because I thought that there was some water in this and that it may have reacted with the water in order to create hydrogen gas, which is very scary. Oh, okay, that's it. Thanks. Be sure to like and subscribe. Cheers.